All right. So what we're going to do today is we're going to be taking notes on a lesson that for many of you is due on April 4th, right? So we're going to be taking notes on, you can't hear me? Can everyone else hear me? Okay, Riley, it's you. Turn your speakers on or turn them up. Okay, so we're going to be taking notes on a lesson that you guys are all going to need to take notes on anyway. And then I'm going to add a little bit of extra information at the end about types of chemical reactions, which is something that you usually wouldn't get until high school. But you're going to get to learn about it now. We're not going to do anything crazy with it, but it is pretty interesting. So I'm going to go ahead and share my screen. And we are going to be going through this lesson called chemical changes. And a lot of us have already gone through the physical changes lesson, right? In fact, I would say 90% of the class has gone through the physical changes. And because of that, right, we're going to be comparing and contrasting physical changes to chemical changes. And then we're going to start talking about chemical reactions, which is probably the most exciting part of chemistry to some people, to most people. So I have a document camera, I think. There it is. Okay, so I have this document camera here. Uh-oh. I'm gonna mute you. Okay. So I have this document camera, so I'm gonna be showing you guys what notes I would have taken if I were a student doing this lesson. Now, obviously I have a little bit of an advantage because I already know the information, right? And I already know what's important. So this lesson is called Chemical Changes. So I made sure to put the date, which I cut off here a little bit, and I titled it Chemical Changes. So anytime I need to find something about chemical changes, I'm gonna start here. If we're looking in the Canvas lesson, right, you guys know, they always have some little like infographic-y thing that you can do. In the beginning, they're asking you, what do all these things have in common? Iron rusting, an apple rotting, coal burning, or leaves changing color in the fall. What do we think? What do all of those things have in common? You can type in the chat. You can speak if you unmute yourself. Any ideas? Chemical change? Yeah, that is an amazing guess, right? The lesson's called Chemical Changes. All these things seem like something's changing, right? And these are all chemical changes, right? So we're gonna find out exactly what that is, how we define that, and what that means. So I know this part of the lesson's boring to you guys probably, but the objectives are so important. So I actually take a couple extra seconds to write down the objectives because at the end of the lesson, we're gonna go back and we wanna make sure that we can do those two things. Sometimes there's three, sometimes there's one, right? But you wanna make sure you can do those things. So we wanna make sure we can identify the characteristics of a chemical change. So we're gonna be looking for the characteristics, right? And then apply the characteristics of chemical changes to examples. So can we see an example and tell if it's a chemical change and why? Okay, so first thing they say here, you have learned that matter can undergo physical changes like boiling or melting without changing the identity of a substance. Yes, I would be taking notes, Paige. That is a great question because what I wrote, you should definitely write. So I will leave the notes page up. I wish I could read. Maybe I can do both. Let's see. Okay. So they kind of reviewed physical change here. I actually took the liberty of writing the definition of physical change again for myself, right? Because distinguishing between chemical and physical change can actually be really hard. And we're going to talk about that in a second. But a physical change is a change that does not alter the identity of a substance, right? So if we start with oxygen, no matter what changes it does, we end with oxygen, right? It's not a new thing. So they gave us some examples here that we could fill in. We can add some more physical changes that we know. But we know boiling is one, melting, right? Others, you could put freezing, right? But any kind of change, it's not altering the substance. So think about water. When water goes from ice into liquid water, right? It's the same water. It's just a different state. So we're able to, Riley, why are you talking about cruises? We're talking about physical changes here. So that's a really good question to ask yourself when you're thinking about it is it chemically different? Right? So I'm going to give you a really complicated example. In fact, I'm going to draw it on this paper as well. So we have a candle. Yes, that's my beautiful artistic candle. I'm going to label it. So when the candle is lit on fire, right? Is the candle undergoing a physical change, or do we think it's a chemical change? We may be wondering, what is a chemical change? It is a change of one or more substances undergo when they become new or different substances. So thinking about that candle. Yeah, I could create a document, but I actually want you guys to practice physically writing notes, right? I think it's important. So the candle's burning. Is that a physical or a chemical change, you think? Let's see, what color have I not used? Physical, okay, we're getting guesses for both. So the candle is probably melting, right? You guys have seen that when the wax like starts dripping off the sides of the candle, right? So in some ways we can say the melting, that is physical, right? The candle's not changing, it's just melting. But what about the flame part? The wick is burning, right? So the wick is actually undergoing a chemical change. That's why the candle is the best example, because it's both. The burning of the flame is a chemical change, right? That wick is actually combusting, which we'll talk about. It means it's releasing heat and fire and gas. But the candle itself is just melting. So that's where this can get hard, because sometimes physical and chemical changes happen at the same time, right? They can happen together. We also call chemical changes chemical reactions. So an example that they give you in the lesson is fireworks. Okay? So they want us to see this video of different stages of fireworks. Whoa. Sorry, I wasn't expecting the sound. Okay. Fireworks, rocket. Okay. Preparing fireworks. You can't even see these. These are so tiny. Okay. Those are useless pictures. We'll ignore those. We've all seen a firework, right? We've seen the explosion. That explosion is a chemical reaction. And so then they start going into how we can tell, right? How do we know when something's a chemical reaction? We already probably have an idea in our minds, right? You can also see what it says in the lesson. But we have characteristics and we have signs of a chemical reaction. I'm just going to let you guys write that stuff down. for about a minute here, and then we can process. And if you're not writing notes at this exact moment, you're reading and you're thinking and processing. What do these things mean? Oops. Sorry, I'm blocking the notes for a second. I want to find these cool GIFs of chemical reactions that we're going to look at in a second. Okay, I think that's them. All right, show me a thumbs up if you're done writing, getting close to being done writing. Okay.
What was the last example? I didn't see it.
The last example here.
Of chemical signs, yeah.
Gas or solid form. Okay, so I'm just going to start reading these. If you're still writing, that's fine. So, characteristics of a chemical reaction. The substances at the end have a different property than the original substance. Chemical bonds break and new bonds are formed. Now, here's the hard thing about this. When a chemical reaction happens, you don't see the bonds breaking and then reforming, right? We don't see that. In fact, it's almost impossible to see that. You can't. We can show slow pictures of what we think is happening, but we can't actually observe that, right? We know that at some point bonds are broken and that they're reforming. It's hard to see. What we do see are the signs. What can we actually observe? A change in color, bubbling or fizzing, right? Think about when we did the Mentos Coke experiment, right? When we put the Mentos in, they started bubbling and going crazy. That should signal to us that maybe it's a chemical reaction. Light or heat is produced, right? With the fireworks, light and heat are produced. A gas or a solid. The solid is called participate, which is like a fancy chemistry word for a chunky solid. So sometimes you mix two liquids together and then a solid happens, which seems weird, right? But that's a sign that there was a chemical reaction, and then also a smell. Sometimes a pleasant smell, sometimes not a pleasant smell. Those can all be signs of chemical reactions. So now, let us go into the world of the internet. And I think this is what I wanted. But 20 amazing chemical reaction GIFs. You guys ready for this? Okay, this is some kind of electricity. What signs do we see here that a chemical reaction could be happening? Riley says it's a yeah, it is a chemical reaction, but what signs are we seeing? It's kind of hard to tell on this one. Yeah, it looks like a solid is forming, right? Like growing, like expanding out from the original shape. Yeah, it looks like Legos building up. Yeah, exactly. So we see some kind of solid forming. This is just 10 being cooled. What do we notice here that gives us a sign that it could be a chemical reaction? Color change. Yeah, right? It starts out as this light gray and then it's turning into this dark gray color. And it's like changing size, right? Which doesn't really tell us chemical reaction necessarily, but that color change tells us that something's going on. This is a cool one. These are huge if this loads. There we go. Looks pretty pretty lovely. Okay, good. Here's the beginning. So what's happening there that tells us that this could be bubbling or fizzing? Definitely, yeah. It's like growing like 18 times the size, right? And it's hard to tell in the beginning, but there's also a color change, right? When he put in that liquid, it changed color slightly. Pretty cool. Okay. What about this one? This is mercury and aluminum reacting. Color change. What's this fuzzy stuff? That fuzzy stuff is a solid forming, right? So a solid is actually forming on the surface there. Okay, you guys are getting the idea, right? But we have so many more of these. Now, okay, what's going on here that tells us that there's a chemical reaction? The flame, right? There's light.
Light or heat production.
The what?
Light or heat production.
Yeah, light and heat are being produced. And then what's going on? There's like alien arms coming out of this thing. What is that? Does it look like a solid maybe? A solid forming? Right? Okay. We'll look at one more because I think you guys are getting the idea of this. Some of these are not the nicest quality. Like this one, you can't really even see what's going on. We'll skip that one. Imagine if you did that in your house. How happy would your parents be with that? Okay, so what do we see there that tells us that it's probably a chemical reaction?
Jamie?
Yes?
I think I might have a video of something like that.
Do you want to put it in the chat and we can watch it? Yeah, there's a lot of fizzing and bubbling. I agree. Like an insane amount, right? It almost explodes. There's probably a gas being produced there. Even though we can't see it, that's what's causing that explosion to happen. And I just like that they tried to put down the sheet so that it wouldn't get everywhere, and it didn't help. Okay. So we're going to wait maybe for a video of this happening. Something like this happening possibly. We're going to move on to I'm gonna mute you. All right, Amaya, making some stomping noises over there.
Sorry, I'm at the doctor with my mom.
No, it's okay. All right. So Riley sent us this video. Let's see. If this is a waste of my time, Riley, I'm gonna be upset. I don't know, but we are gonna have to watch an ad.
It's Hannah. Hannah Baker. I'm about to tell you this.
Okay, we don't care about you, Hannah. Okay. Whoa.
So YouTube, today we're going to make elephant toothpaste. Okay, so I have my safety goggles on, my safety gloves on. Let's explode some stuff. If you don't know what it is, giant volcano. That's basically it. Kids, don't try this at home. It's very dangerous. So we have here some hydrogen peroxide. We're gonna pour a little bit of this here.
So hydrogen peroxide, that's the stuff that you guys might have had poured on cuts that you might have gotten. Anytime that your mom or doctor or parent or somebody tried to like clean one of your cuts, it like bubbles and burns and cleans it.
Oh yeah, look at that. Now we have some green food coloring. We're gonna make it all colorful today. Keep in mind, I have never tried this at all, so I don't even know if this is gonna work, but it's worth a try. Now grab some dish soap. Put it in here, a little bit right there. Now just mix it around. Oh, dude, I feel like a scientist, dude. Look at that. Oh my God. Oh my God.
Riley, is this what you watch all the time?
Last but not least, we have the catalyst, which is sodium iodide. As soon as I pour this in, I really hope it works. Whatever, let's try it out. And here we go. Whoa! What? What is going on? Oh my gosh! That thing reacted so quickly. It threw me off guard. Oh my goodness. That was amazing. It's still doing its magic right here. You guys can tell. Oh my gosh. Look at all.
Okay. Right. Thank you, Riley. So that's like a explanation of how you would make that. Right. But really, what's interesting too is that we notice the chemical reaction quickly starts and then they keep going. Right. In fact, they're going to react as long as there are items to react. So he could pour more stuff in and it would just keep going and keep going. So now we're going to look at some advanced high school stuff here. We're going to look at the types of reactions. They don't go over this in the Canvas lesson. This is special stuff here, right? But we have these 5 basic types of reactions. And we're going to kind of break down what they mean and look at an example. And then we're going to kind of talk about how we name and number and label these compounds and sort of how to read them. And then that's going to be the end of this, right? This is a pretty short virtual session. So again, I'm going to give you guys a minute or so here to write this down. If you can't, let's see if I can zoom in. How do I zoom in on this thing?
I can't really do that because I'm at the doctor's office and I left my backpack in the car.
Okay. So you're
So
reading
can,
and thinking.
so can I screenshot it?
Yes. Okay. Can we all see what that says, or do you want me to try?
Can you zoom it in a little bit?
Ooh,
Thank you.
is that too much? That might be too much, huh? Let's see. Okay. That might be the best we're gonna get there. What is this thing? Oh. Okay. Sorry. So there are only 5 types. Yeah, these are the basic types page. They can break it down even more in more advanced chemistry classes where like replacement reactions, there's different kinds. There's single replacement, double replacement. There can be more complicated versions, but these are the basic kinds that almost every reaction fits into. And the best part about them is that the name kind of tells you what's happening. So synthesis, what does the word synthesis mean? Reaction, that's a good yes.
I was gonna say, isn't it more than one? Or
Yes, it means to put things together, right? So if I'm going to synthesize something, it means I'm making something with things. So in a synthesis reaction, we might even want to write under synthesis to make. You're taking many single things here. In this case, we're taking hydrogen, we're taking oxygen, and they're synthesized or put together to make water. So anytime we would see a synthesis reaction, we're taking elements or compounds and we're putting them together to make something new. Decomposition is going to be the opposite of that, which we can think of the word decompose. What does the word decompose mean?
To break down.
To break down, right? We can think about decomposition of soil, right? In a decomposition reaction, we start with one big thing, we break it apart into smaller things. Replacement reaction, what does it mean to replace something? Yeah, something new, to replace it with something new. So in a replacement reaction, this isn't real, by the way, right? Because we don't have elements called X, Y, and Z. But they're showing us here we can take anything that's an X, Y, add a Z to it. If the Z and the Y end up switching places, that would be a replacement reaction, right? In this case, the Z comes over and replaces the Y. There's a lot of different examples of that one, but that's like the basic concept construction of it, right? Is that something is replacing one of the elements there. We also have acid-base reaction, which we have already learned about in previous lessons, that when we add an acid and a base, what do we get?
A neutral compound.
Yeah, what is this right here? H2O. We get water, plus we get a salt, right? This is a salt. KBr, potassium bromide, is a salt. Oops, my S turned out a little weird there. So anytime you add an acid and a base together, you're going to get water and a salt. And then the last one is combustion reaction, which, Riley, this one's going to be your favorite. This is the explosion one, where you take
ooh,
exactly. You take something and usually you add oxygen to it and it will explode, right, and produce gas and water. Sometimes it produces other things. But you can think of combustion, like those are the kinds of reactions that happen in car engines, which is very useful if you enjoy traveling around in a car, which I would say most do.
We actually saw a car that was on fire on the freeway. That probably happened.
Too much
Combustion.
combustion happened and it resulted in fire. Yeah, definitely. Right? Because if you think about it, gasoline is also very flammable, right? So anytime something goes wrong and there's a spark and there's heat and light released that maybe it shouldn't be, gasoline's gonna whoop in flames. Pretty scary stuff. Okay, last thing I wanted to touch on before we're gonna play a little game where you guys are gonna guess which type of reaction something is how we read and write and talk about these things, right? So this is a compound. I just took this one from the decomposition reaction example, right? What does this mean? We see all these letters and numbers here, right? The first thing is we see Pb, which we can actually find on the periodic table. That's lead. Okay, so that stands for lead. We have an NO3. NO3 is nitrous oxide, I believe is how you say it. Some of them are said slightly differently, so I could be wrong, but it's a nitrogen with 3 oxygens. So the way that this compound would look is it's a nitrogen that's connected to 3 oxygens, right? That makes one of them. We have this little 2 here, which means we have 2 of these compounds and 1 element of lead. If that makes sense, right? So when you see these little numbers, they tell us in this case that we have 3 oxygens in one of our compounds. And then when there's something in parentheses with the little 2, it's kind of like math, right? That means we have 2 of those whole molecules that are in the parentheses, right? We're used to seeing compounds that are a little more simple, right? Like NaOH, where there's no numbers. That means we have 1 sodium, 1 oxygen, 1 hydrogen. But we could.
So what would that do?
What does that do? That is a base. NaOH is sodium hydroxide. So that is that what makes up bleach? I want to say that's what pure bleach is. Pretty sure it is. And what gets hard is, how many compounds do you think there are in the world?
Infinity?
Yeah, there's millions, right? So that's when it gets hard too, because sometimes like I recognize some of these compounds immediately, and others I'm like, I have no idea what that is, right? But I could still read it. So even up here, C4H10, I'm not sure exactly what compound that is, but I know it has 4 carbons and 10 hydrogens, right? O2, I know has 2 oxygens. CO2 has 1 carbon and 2 oxygens, right? So you can still kind of read even this lead thing. Do I know what that looks like or does? No, right? But I can still read it. There's lead and there's this nitrogen oxide compound attached to it. So that was a little introduction to what your high school chemistry life is going to be like times 1,000, because it's going to be way harder and you're going to have to memorize
Wait,
all.
to memorize, please?
In high school.
Not for now, but in high school you will.
And I
Oh.
had done this in my previous school, but it's basically kind of like the same thing. But why are they just having it taught in high school instead of, or why are they having it like done in middle school when it's supposed to be in high school?
That's a good question. I just wanted to introduce you guys to it because I felt,
They want to prepare us.
yeah, I felt like the information provided in the lesson, just how to tell that there's a chemical reaction happening, that seems pretty straightforward, right? We can look at something and say, oh yeah, it smells, there's a color change, it's bubbling, right? This is getting into more what's actually happening in those reactions. And the more you hear about these things, when you get to high school and they say synthesis reaction, you're going to be like, oh yeah, I've heard of that before. Now, okay, what is it again? Oh yeah, that. And it's just going to be a little easier to understand, right? And reading compounds and being able to identify what's in the compounds, right? That kind of stuff is super important for being able, it's like learning the language of chemistry. So I just wanted to introduce you guys to this so that you're prepared when you hear it again. You're like, oh yeah. And now if you're super interested in this, you can take it to the next level. You could research these things on your own. Right now that you know the types of reactions, what they kind of look like, you could go and say, you know what, I want to learn more about synthesis reactions. What are they? You know, when are they used, etc. So we're going to end here with a little game called Which Type of Reaction Is It? So we have 4
I'm going to fail at that game.
It's going to be fun. There's 5 choices, right? So take a second here, look at these 4, and try to decide, is it a synthesis reaction? Is it a decomposition reaction? Is it a replacement reaction, acid-base reaction, or a combustion reaction?
Sorry, I didn't hear the question. What was it?
The question is, looking at these 4 things, these 4 different reactions, try to figure out which type of reaction they are. Or is it a synthesis, decomposition, replacement, acid base, or combustion?
Do you just say what you think it is?
Yeah, let's start with the first one. What do you guys think of for the first one?
Wait, the second one?
The first one, we
Oh,
have calcium.
I think that one might be an acid base.
Okay, so let's look at it. We have a calcium. We have 2 HCl, which is an acid. Okay. We end up getting calcium chloride and a hydrogen gas. So if it was an acid-base reaction, we would get water and a salt. Did we get water and a salt here?
No.
So we
Is
can
it-
say it's probably not acid-base. What's
Is-
happening though? I see calcium coming to join that chlorine,
So,
right? We're not putting things together. We're not taking things apart. I would say the best answer for this one is that it's a replacement
that's what I was going to say.
reaction because the calcium is taking the place of the hydrogen, right? And the hydrogen is getting released as a gas. Okay, second example, we have 2 potassiums. I know potassiums with a K, 2 waters, and we end up getting this over here. What do you guys think? This one's kind of tricky.
Decomposition reaction?
Decomposition, are we taking something and breaking it apart into a bunch of things? Kind
No.
of. What's happening here? Well,
Bad at this.
yeah, no, this is hard. I'm telling you, this is hard stuff. And I didn't pick easy examples. So what I see is that in the end, the potassium is attached to an oxygen and a hydrogen. Where did those come from? They came from the water. This one is also a replacement reaction. It just looks a little bit different. The potassium is taking the place of one of the hydrogen molecules, and then the hydrogens are basically getting like shoved out. What about the third one?
The third one looks like a decomposition reaction.
Good. This one looks like decomposition, right? It is. We have one big molecule. We're breaking it apart into smaller
That's
ones.
what I was gonna say.
Good.
Blow your mind.
And then what about the last one? What do you guys think?
Synthesis reaction?
Synthesis. Right? We're taking phosphorus, we're taking oxygen, and then we're making one giant phosphorus oxygen molecule. Okay. That was your introduction to chemical reactions. And really, what we want to do now that we've finished the lesson / my little extra stuff that I made you do here, we want to go back to these objectives and we want to make sure, can we do these things? Can we identify the characteristics of a chemical change? Can we do that?
Yeah.
I have a question.
Yes.
Since I'm not on like a normal computer, I'm on my phone.
Mhm.
On the live lesson, can you send me pictures?
So I'm recording it, so you'll be able to go back, and I'm also going to take pictures in the notes.
Okay, that's what I was asking.
Great question. So characteristics of a chemical change, can we identify them? Yeah, right? First of all, we wrote them down, so we can always look back at them. Second of all, we know there's going to be new substances, new bonds. We know the signs of a chemical reaction. They don't even ask us about that. Can we apply the characteristics of chemical changes to examples? That's what we did with the chemistry GIFs, right? I had you guys identify signs and characteristics of what was going on to help us identify that a chemical change was happening, right? So you did both of those things. You just want to go back and check, do I have a pretty good understanding of those two things? If you feel yes, then you're done. If not, I would go back, look at the notes again. You can always type this stuff into YouTube, right? Like when we found this great YouTube video, you could always type chemical reaction in. There's tons of really great science videos. There's also some kind of weird ones, right? But a lot of them will talk about chemical changes, chemical reactions, what are they, and go through some more examples, some more basics. So you can always find additional things to watch if you feel like you need to hear more about it. Okay.
I might do that.
Yeah.
Mrs.
And
Dinsmore?
now that you know about these different types of reactions, I encourage you to pick one that sounds interesting to you and read more about it or watch a video about it, right? Because they'll go into details about specific elements, specific compounds, how they react, right? You can learn so much about really basic stuff that you might use every day that you're like, oh, wow, that's what reacts. Right? It's this reaction. So I'm going to leave you guys for now to have an amazing spring break and maybe use spring break to catch up on stuff if you need to. All of these notes will help you for your assignment that's going to be due on April 4th for most of you. Some of you might have a slightly different date, right? So now when you get to chemical changes, you already did the notes for it. Hopefully I helped you kind of understand what it is, and you'll be able to start on that assignment.
Mrs. Dinsmore?
Yes.
Since we already read through the lesson, can we go ahead and do the quiz after the live lesson?
Yep. And that was my hope, is that you could do it right now, or you could do it next week or after spring break, right? And I already helped you get through the, I think, hardest part, which is going through the lesson and taking the time to actually read all of it. All right, any other questions or thoughts on this?
No, not really.
Riley says, see you the week after this week. Yes. Who did this?
Amaya?
Oh, Amaya?
Amaya?
Oh, and when is the next live lesson?
Good question. Look what I have here. Your art.
I'm putting it up.
What was that? I couldn't see it.
In his office. When is the next live lesson? Let me check on the calendar and I will let you know before I end this meeting. Okay, I guess I don't need to share my screen
So
for
you
this.
say Amaya too. I say Amaya, but Mr.
And was that my picture?
It is your picture and it's getting hung up right now.
Yay!
I have a question for you.
What was that picture? I didn't get a good look at it.
I drew it.
So Mr. Baker calls you Amaya, but Miss Dinsmore and I call you Amaya. Which would you prefer?
Wait, what?
Well, I told Mr. Baker that you drew this.
Uh-huh.
I refer to you as Amaya, but however, I've noticed that Miss Dinsmore and I call you Amaya.
Yeah. Some people call me Amaya, some people call me Amaya. I go by Maya or Amaya. It just depends.
Okay, that's what I thought.
Me Amaya because I can't say it right.
Gotcha.
Okay, so on the question of our next virtual session, our next lab is going to happen before our next virtual session. Is going to be on Cinco de Mayo, May 5th. We are going to be making rockets with different shaped wings, and I'm going to be ordering a rocket launcher, and we're going to launch them.
I'm gonna actually
Probably
launch.
going to be an air launcher, not like a explosion fire launcher. But
Is it on Friday?
Yes.
it will be on Friday, May 5th.
Mrs. Dinsmore, is there anything to submit for this, or?
Is there anything for you to submit for this? Nope.
What I did when I was in the 6th grade once is that I did water bottle rockets.
Water
This
bottle
water rocket.
different wings so that we can determine which type of wings are the best.
Flat ones.
It's gonna be cool. Okay, so May 5th is our next thing, and we'll be doing the lab at the school, right? 9:30 to 11:30. We'll probably We might do it all at once with everyone, just because you're gonna have to cut out your rockets and stuff. It's gonna take some time. But otherwise, that's the next time that we're gonna meet. Don't forget about your SBAC testing, first week of April.
And
Right.
when is the book gonna be done?
When is what gonna be done?
The book that the artwork is still in?
The book that the artwork is still in.
No, the book that is all the work. I can't talk. The book that all of the work is gonna go in.
Oh, I don't know. I don't know when that's gonna be done.
Dang it.
That's a good question. Where are we gonna launch the rockets? If it's nice outside, we will do it outside.
Yay!
If it's raining, we'll probably do it in the hallway. So fun places for everyone, hallways and outside. Okay, so I'm gonna end this meeting. You guys feel free to email me if you need help or have questions. Aww.
Hi. Hi. She waves.
She's like, what's this Zoom session? What is this?
No, the whole time that you were talking, she kept waving and kicking her feet and shaking her head no.
Aww.
So I was like,
chemical reactions. She's like, no more chemical reactions.
she does that with Mr. Ling too.
That's cute. All right, I'm gonna end the meeting, guys. Have a great spring break. I took a picture of everyone who attended, right? Like your names, so I have a record of that. All right, I'll talk to you guys soon. Bye.
Bye.